Hello everyone, welcome back. In this video, I want to start talking about how to find the equation of a line and all the different ways our lines can be represented by an equation. And so we have three forms that our linear equations or lines are generally represented by. The first one is the general form, which we actually work with the least often. It looks like ax plus by equals c. We call this the general form because any line can be expressed using this equation, while not every line can be expressed using our other forms. It's kind of a technical detail, but technically we cannot express vertical lines using these other two forms. But this general form can represent vertical lines, horizontal lines, slanted lines. Literally any line can be represented by that general form equation. So the form that we end up using the most often and that is the easiest to work with in most students' opinions is the slope-intercept form. That looks like y equals mx plus b. We've actually worked with some equations in all of these forms already, but slope-intercept form is the best one to work with. So in this formula, x and y are representing an arbitrary or random point on our line, and then these other quantities m and b are representing very special features on our lines. And so what we've seen what m represents before, m is representing the slope of our line, which we can calculate using that slope formula, the change in y over the change in x, or y2 minus y1 over x2 minus x1. And b also has a very important interpretation and represents a very special piece or point on this line, and that is the y-intercept value. And so remember, if we want to find the y-intercept, we have to plug in x equals 0. If we plug x equals 0 into our equation, that first piece vanishes and we see y is equal to b. So the y-intercept is the point 0, b. So why is it so nice to work with a slope-intercept form, and why is it preferred over these other forms? Because from the slope-intercept form, we can immediately read off what the slope of the line is. It's just that number in front of x, and that constant term that is added on at the end, or sometimes in front of that first term, we know that that is the y-intercept, and that can be like the starting point of our line. So we can graph that y-intercept point and then use our slope to navigate to other points that we know our line must go through. So the third common form that we express our linear equations or lines in is this point-slope form. It's actually pretty similar to our slope-intercept form. M is still representing the slope of our line and is calculated in all the same ways. For the slope-intercept form, we have this very special point that our line goes through, 0, b, the y-intercept. Well, point-slope form lets this other x1, y1 value represent a point on our line. That point could be the y-intercept, or it could be literally any point that we know our line goes through. And that makes it a little bit more powerful, or a general form, because we can plug in any point the line goes through. Well, for slope-intercept form, we have to know that very, very special y-intercept point. And so in point-slope form, x1, y1 can be any point the line goes through. All right, let's go ahead and do an example of finding the equation of a line. So we want to find the equation of a line through the given points of 3, -2, and 4, 0. We do not need to graph the line to get this done, but having a visual aid is often pretty helpful and allows us to kind of check parts of our answers. One point is 3, -2, so we have to go right 3 and down 2. That should be right about there. And I originally wrote that second point as 4, 0. Let's go ahead and make it -4, 0 instead. And so that'll be our x-intercept, which will be over there somewhere. And so now if we draw that line through our 2 points, we can visualize our line. We can see our x-intercept is negative, our y-intercept is negative, and also our slope of our line should also be negative. Remember, the slope is representing the ratio of that change in y to the change in x as we move from point to point. So if our change in x is moving in the positive direction and our y value is going down, that ratio is going to be negative. And when we have a negative ratio or a negative slope, that means our lines are going to be pointing downwards. The steeper the slope, or the steeper downhill we are going, then that means the larger negative number we are getting for the slope value. Well, on the other hand, if our line is pointing up as we move from left to right, then that indicates a positive ratio of the change in y to the change in x, or a positive slope. And again, if our positive slope is pretty close to 0, then it's not going to be a very steep line at all. But the larger and larger our positive slope becomes, it's going to get steeper and steeper. All right, so now let's go ahead and actually find the equation of this line. And when we're given 2 points, the first thing we always want to find to start building up our equation is the slope. So let's start by finding the slope of this line. And so we just have to choose a labeling for our points, like which one is x1, y1, and which one is x2, y2. Let's go ahead and call our x-intercept x1, y1. And this second point, 3, -2, we'll use as x2, y2 in our slope formula calculations. So remember, the numerator of our slope formula is the change in y values. So that'll be like -2 minus 0. y2 minus y1 gives us that -2 minus 0. And in the denominator of our slope calculation, we have to represent the change in x values. So that'll be 3 minus -4 when we're looking at x2 minus x1. And we have to be pretty careful there because we're getting a double negative. So our numerator simplifies to -2, while our denominator simplifies to +7. So now we know the slope of our line is going to be -2/7. And we see that in the picture we drew, we have this negative slope. So our end goal is to find the equation of this line. And let's go ahead and say we want to write our end equation in slope-intercept form, y equals mx plus b. Well, we can't get there right away because we don't know what the y-intercept is. Based off the quick sketch I drew, it almost looks like our y-intercept is -1, but we shouldn't trust our hand-drawn graphs with information like that. We should instead verify it algebraically. And so there's a couple ways we can go about doing that. A really common way is, well, we know so far our equation in slope-intercept form has to look something like y equals mx plus b, but we just found our slope or m value to be -2/7. So y is equal to -2/7 times x plus b. We also know our line has to go through these 2 given points. And so that means if we plug this pair of x and y values into this equation, we'll be able to solve for b. Or we could instead plug this pair of x and y values into our equation and solve for b. It will not matter which pair of x and y values we plug in. Either pair will result in the exact same value for b because all this stuff is coming from the same line with that one fixed y-intercept. So we just have to make a choice and stick with it is what that means. And well, it's always nicer to plug in zeros. So let's go ahead and use that point x1, y1 to help us find b. So y is 0. So we're plugging in y equals 0, and x is equal to -4. So we get -2/7 times -4 plus b. Well, let's see. -2/7 times -4 is going to give us +8/7. So our right-hand side simplifies to 0 is equal to 8/7 plus b. Well, to get b by itself, we have to subtract that number 8/7 from each side. And we find that b is equal to -8/7, which is just a little bit smaller than -1 or a little bit below -1 with how we've drawn our y-axis here. And so that means our graph was lying to us with the way I drew it. The scale wasn't accurate enough. It's close to -1, but it's not exactly -1. And so now we can actually write down the equation for our line. I'm going to go ahead and put it up here because we might run through this example again. So our final answer is looking like y is equal to -2/7 times x plus b, but that b value is -8/7. And we don't need to write plus -8/7. That'll just be -8/7. And so technically we are done with this example. We found the equation of the line through those 2 given points. This is the equation of that line. And so remember, our steps for doing this were, first we calculated the slope. We got that to be -2/7. And then we plugged one point we know our line goes through, as well as our slope value into this slope-intercept form. That allowed us to find that last piece of information, that b value, which represents the y-intercept of our line. But we also could have found the equation of this line using point-slope form instead, and that's what I want to look at next. All right, so we got to back it up and clear our space a little bit. If we're going to use point-slope form now to find the equation of our line, construct the equation of our line using this point-slope form, we need to know the slope, which we already got, and then we can use any other point that our line goes through, like that point that we've labeled as x1, y1, but the equation would be exactly the same even if we used this other point x2, y2 in this formula instead. But let's go ahead and see. If we look at y minus y1, well, that'll be y minus 0. That's equal to our slope m of negative 2 over 7 times the quantity in parentheses x minus x1. Remember, the x and y without the little subscripts are our variables that represent any random point on our line, while the x and y values with the subscript of 1 in this case represent an actual numerical value from a point that we know is on our line. So that's why our y1 is 0. And now we're going to plug in x1 to be negative 4. And again, we always got to watch out for those double negatives because x minus x1 is going to look like x minus negative 4, and that'll simplify to x plus 4. So the left-hand side is y. The right-hand side is negative 2 over 7 times the quantity x plus 4. And that is our equation expressed in a point-slope form. But what's really nice is we can always convert an equation from point-slope form very quickly to slope-intercept form just by solving for y on the left-hand side of our equation and then expanding and combining like terms on the right-hand side. And that's a really useful thing to know how to do and to be able to do because remember, from the slope-intercept form, well, both forms we really immediately find the slope of our line, but from the slope-intercept form, we can find our y-intercept very quickly, which is not necessarily clear if we leave our equation in point-slope form. Okay, so remember, we got to isolate y on the left-hand side and expand and combine like terms on the right-hand side. And so if we distribute that factor of negative 2 over 7 throughout our quantity in parentheses, negative 2 over 7 will get multiplied by x, but it'll also get multiplied by 4. And we multiply negative 2 over 7 by 4, we get negative 8 over 7. And so now we can much more clearly see the y-intercept of our line because we've taken our equation in this point-slope form and re-expressed it in slope-intercept form. And what do you know? That's the same equation we got the first time we did this example. And that's what should happen. We need that kind of consistency, right? But it's really important. We need to be able to find the equations of these lines. The process always starts in the same way, where first we find the slope. And we find the slope by using those 2 points that we know our line goes through, as well as our slope formula, although sometimes the slope will just be given to us. And then after that, we really have a choice of whether we want to work with slope-intercept form or point-slope form. Sometimes that'll be determined by the exercise we're working on, or the choice will be up to us. But then we can also remember if we did use something like point-slope form to construct the equation of our line, but then the problem asks for our answer in slope-intercept form, we can always go through a process similar to this to expand and simplify and rewrite our point-slope form equation in that slope-intercept form.